Anyway, time to stream. So, I had a lot of fun with this earlier in the week, and I wanted to play some more. Mostly because we unlocked fertilizer, so I kind of want to do fertilizer stuff. We were working on pumpkins. So if you weren't, let's just note this as party seeds. So if you weren't around earlier this week, this is a game where we are a little drone, and we are basically automating our farm using Python. So we are currently planting hay. So we've got a function here that is just harvesting all the grass. We have a function here that's checking how much hay we've got. So now we've got enough hay, so what we're doing is we're planting trees. So that's this function over here. And trees grow in a particular way. So they need space to grow. So it only plants in certain things. So once the wood is up at 2500, it'll start planting carrots, which is down here. So you can see it started to plant carrots now, so it's harvesting all this. And away it goes. And then the last thing we did, and this will not take long. And let's just upgrade carrots. Just makes carrots work quicker. So we've got all our wood that we need. So we're just going to plant a load of carrots now. And you can hear it watering the crops. So now we're going to start planting pumpkins. So what it does with pumpkins, they merge. And it just has to check all the spaces. And then it harvests them. And the bigger the pumpkin is, the more you get. But the pumpkins have a chance of dying. Will instantly grow the plant under the thing. Fertilizer dries up the ground, the water speed buff will still apply. After that, the water level of the ground will be reduced to 0. So I think we can do a bit better with this. I think we can do a bit better with this. Let's just stop this. We'll just clear this. Yeah, wood was used in the upgrade, so this function will check hay, then it'll check wood, then it'll check carrot, then it'll check pumpkin. So if any of those drop, it'll start doing those. So this pumpkin function I think is pretty good. And it will actually go through and do them all. But it has to scan everywhere. So I kind of want to rewrite my traverse grid a little better. And I think what I kind of want is like a go-to function. Because if I can get a go-to, then I can check where the empty spots are and keep track of them. So go-to will have an X and a Y coordinate. And we'll just say go to 3. If I got random? No, I don't think there's a random. So if we say go to 3, 3, I want it to go 1, 2, 3, 1, 2, 3. So what we can say is x equals get underscore pos underscore x, y equals get underscore pos underscore y. So we get our current xy position. I'm going to change this to target target underscore y and target x, just so we know. So what we want to do is we want to move north or move south, depending on. So we say our current x minus our target x so if that is less than 0, so that means our current x is above, we want to move south. Otherwise, so actually let's because I'm going to do this a couple of times. So we say move x equals so if it's less than 0, we move south. If it's greater than 0, we move north. I don't actually need. Yeah, it needs to be an elif. Otherwise, we do nothing. So you move x minus target x. Why are you not? You'll go to 3, 3. You should move south. X is equal to 5 minus 3. That's positive. You should move south. Got them the wrong way around. So it shouldn't need else do nothing. Because if it's 0, I don't want to move north or south. Right, hang on. Here, x is... Right, let's do this again, but let's actually move... Let's actually do this in the right thing. We want to move y, because north-south is y. So 0, 1, 2, 3. There we go. Now we say if... Now we say move x is equal to x minus target x. And in that case, if x is less than 0, we want to move west. Elif move underscore x greater than 0, then we move east. Nope, other way around. East, west. So we're there. Right? Okay. So that will do it once. So if we clear that, that will just sort of move once. So I don't want to have to keep recalling this. So what I want to say is if move x is equal to 0 and move y is equal to 0, if move x is equal to 0, I can do this the other way around. If they're not 0, then call the function again. Do this recursively. Can I do that? If move x is not equal to 0 and... Yeah, you're right, it should be an OR. So here, let's say 0, 0. And then we say 5, 5. Goes all the way over there. Nice. So we've got a go-to function now that we can use. We can make this more efficient, because if I move east from here, I actually end up here, which is quite handy. I can also do this just to clean this up a little bit. And if I make the, and if I actually make this an elif, and then say go to yeah, that instead of going whoop, 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 and I always have to do this here, so this will finish when it gets to the right size. So that I think works. And let's just say reset underscore drone is go to 0, 0. Just in case we need that function. So instead of empty spots being false here, what I want to do so this wants to be a while. Let's just do this. Def plant pumpkins 2. Right. Empty spots. And this wants to be an array. And it wants to be an array of coordinates. So, you know, it wants to be an array like this. So how can I create an array? I want to create an array which has all the coordinates in it. So wants to be like an array of tuples. So what I could say is for x in range get underscore world underscore size, for y in range get underscore world underscore size. You're an array dot push so I could do that, and now let's print empty spots. This is not for n in range. It's just like it's this. I need to unlock lists. Okay, fine. Empty spots dot append. Right. Do I have quick print as well? And let's have a look here. Yeah, and the world is not going to be always a 6x6. You can expand it. So not yeah. So this is good. But the world is a toroid. So if you go north, you end up on the bottom, and if you go east from the left, you wrap around. So you can make tuples. Tuples are a great way to combine multiple values into one. You can unpack them. So actually, can I unpack? Can I do that instead? Yeah, that's even better. Right, okay, so we've got our list of spots. So now we say, while can we say length empty spots is greater than 0. I don't need that. So while we have empty spots, I want to go to, so I want to say empty spots dot pop. So I should be able to say empty spots dot pop, and it removes the last element from a list, or removes the element I. So we could work backwards. So we go to XY. And then we plant a pumpkin. Okay, so that's basically planted all the pumpkins. Now, a fifth of these will die. So what I need to do is basically, do you pop the first one? Remove the last element. So if I say pop the first one, let's do a clear. So let's pop the first one instead. Right, so you end up there. Right, so I want to plant a pumpkin, and then I want to append XY onto this. So what I say now is if get entity type is not equal to if get entity type is not equal to entities.pumpkin, so if it isn't a pumpkin there, I want you to plant it and then add this back onto the list. So what you should see this do is try and plant on all of these. And then when we're out of this, we just harvest. So it'll do this, do this. Yeah. I don't know why it didn't harvest there. While length of empty spots is greater than 0, pop there, empty spots not append, and then eventually harvest. So you check all that, you check all that. So now it's going to check every spot again. Ah, you did harvest. It's kind of weird. Maybe what I do is I harvest at the start of it. I mean, it gets harvested there. So this is where the go-to probably does want to be a little better. Probably seems alright. What I could do is say go to send it to 0, 0. Like, so just reset the drone. Yeah, that feels good. So let's use that instead. So now this is the old method. I'm going to keep it around. This feels better. This is not ideal. What I'm going to do is say this will be get all chords, because this feels like something that will be used multiple times. Chords. Oh, I need to return chords. But yeah, they take a second. They do take a second to grow. But sending it back to 0, 0. So let's do another go-to. Target X, target Y. And let's think about how to do this faster. So we want to get our current. We do want to get our current. Yeah, basically, if it's close, if it's quicker to go the other way, then it wants to go that way. So if I'm at 0, 0, and I want to get to 5, 5. This will be 5, and this will be 5. So I kind of want to check whether half world size is equal to well, you kind of want to do it the other both ways, don't you? You kind of want to go do this and then move underscore y underscore back equals minus get so if we're on 0, 5, this will be positive and this will be negative. If we're on 5, 5, so I wonder if the absolute value maybe what it is, hang on. If move y back is greater than is less than 0, if move y back is greater than 0, then move north. Else move south. Is that right? Let's just move that out of the way. Nope. Plant trees, go over there. Go to fast, go to 5-5. Fast go to, and let's just step through this. So move Y here is -5. Move Y back is 5. Let's just set drone. Nope. That's not quite right. So if move Y is less than 0, or move Y back is less than 0, then move north. No, that's not going to be right. It needs to be an and. Or we need to relate it to the world size. Or we need to relate it to the world size. Yeah. So the size of the world is get world size. So basically, if the position of this, so our target is 5-5 here. Now, if I was here, then I would go that way. If I'm here, then I want to go there. 1, 2, 3. It doesn't matter. 1, 2, 3. So if I'm here, let's take the simple case. Let's take the simple case. I'm trying to get to here. So I'm trying to get to I'm trying to get to here. So if my current X position is less than half the world size, then I want to go the inverse direction. So I want to go the opposite direction. If is less than or equal to size divided by 2, then move the opposite way. Else move. So here we're trying to get to here. So this should mean that I go south. So move y is less than 0. Okay, so that worked. So now if so now I'm trying to get so this way I'm trying to go down. So here this needs to be north. This needs to be south. So here no, this did want to be south. Okay, this seems to be working. So now if get pos x is less than or equal to size divided by 2, move no, I think you want to be east and you want to be west. So move x is less than 0. So I want you to go west. And here we say if get underscore pos x is less than or equal to size divided by 2. Move east. So 0, 0. Okay, cool. So now let's say 3, 2. Perfect. Why are you... Okay, move y is there. Get position y is less than size divided by 2. So you're going to move north. Maybe we need to compare required distance to move to world size. Yeah, maybe Euclidean distance. So the distance... So the distance is the absolute value of move y here. That's the absolute value. So if we're trying to go to 3, 2, which is like here, on the y, I'm at 0, -3. So I would expect to go north here because my absolute distance... Is that right? North, south. I need utilities. Okay, fine. So let's just try that. One, two, three. So here, if you go 5, 2, that's not quite right. So let's send you to 0, 0. Let's get you to 0, 0 again. So I want to go to 5, 0. So we're going to be here on our move X. So because our absolute value is greater than size 2, we're going to move east. So it should be this. Should it be that? No, that should still be west-east. So then it goes to there. So you go to there. There. 1. Now if you go 5. Yeah, that works. That works. So let's go to 0, 0. And let's go 5, And let's go 0. And let's go 2. 5. And let's go 1. Okay, that fast go to seems to be working. So what we can do I was going to try and see if we could combine these. But I think this is okay. So now we say instead of that, let's use fast go to. And where's my... Where is reset drone defined? It's there. So now let's plant pumpkins. Ah, you need to wait. Now you're too fast. Now you're too fast. So the other option is to fertilize everything. So let's have a look at fertilizer. At some point, waiting for the plants to grow is just not efficient enough. Fertilizer can make plants go much faster. Use items fertilizer will instantly grow the plant under the drone. So we want to go use item items dot fertilizer, and then we water the ground again. But what we also need to do is buy fertilizer. So we've got fertilizer. That's not quite right. I actually want to... What I actually want to do is... I want to do this here. And in fact, using fertilizer is actually just... I bet there's still a chance. And we just check. That's probably pumpkins as good as we're ever going to get them. And fertilizer costs 10 pumpkins. So that's pretty cool. Sunflowers, mazes. You need 3k. I'm not going to do polyculture. So let's unlock sunflowers. So sunflowers, you plant in the same way that you plant carrots. When you harvest a sunflower, the power of all the sunflowers on the farm flows together into the harvested plant. Thus, harvesting a sunflower equals power equal to the square root. Oh, so this doesn't always happen, which is good. Thus, harvesting a sunflower, only one of the sunflowers with the most petals can handle this. If you harvest a sunflower that doesn't have the most petals of all the sunflowers on the farm, the power will destroy all the sunflowers. You can measure to return. Several sunflowers can have the same number of petals, so there can be several sunflowers with the largest number of petals. In this case, it doesn't matter which one of them you harvest. As long as you have power, the drone will use it to run twice as fast. Okay. Okay, so let's have a look at how... Yeah, so just to answer that question, it is trying to immediately replant. So what this is doing is it's checking whether what's underneath is not a pumpkin. And if it's not a pumpkin, it will harvest it, it will plant a pumpkin, it'll water the ground, it'll use fertilizer, and then it'll water the ground again. Which means it will try multiple times if it keeps dying, which is good. Because it means I don't have to go back to it all the time. If this were instead an if, let's go harvest. So if this instead was an if, you see we're not having as much success. Oh, we've missed that one. So I think this being a while just hits it quite a bit more. Because there's no point moving if we know it's failed. If we're here and we know it's failed, there's no point moving off it. Oh, that was still pretty quick. Ah, that's because I've run out of fertilizer. Why am I not buying fertilizer? I need to buy more fertilizer. So actually, let's make this buy. Let's buy like a ton. That might be too much. Yeah, I think that's too much. World size cubed? So there we've got a lot of pumpkin seeds. That is altogether too many pumpkin seeds. So maybe actually, let's do world size squared. If the number of those is less than world size, let's do 2 times the square of the world size. Right, anyway, sunflowers. So we want to plant... So we want to define plant underscore sunflowers. And then we want to define harvest sunflowers. And then we've got a function called plant sunflowers. So first thing we want to do, if we buying sunflowers, we need to buy the seeds. Whoops, I keep... Right, I'm just going to move this go to, like, all the way over here. Where's my main gone? Main's over here. I keep pressing main. Also, plant pumpkins is pretty good now, so I can throw that over there. I am running out of fertilizer still. Right, stop that. So what we need to do is first things first. Plant underscore sunflower grid. So this is going to be my orchestration function. So you're going to buy sunflowers, and then you're going to plant the sunflower grid. So you are now going to Um, while I want to fast go to reset drone, and then we say while get position X is less than or equal is less than get world size. So while position X is less than or is less than the size -1, and get pos Y less than or equal to size -1. So we check the ground. If the ground type is not equal to grounds.soil, then we till the ground. Then we say get entity type is not equal to sunflower. Then we're going to harvest. We're going to plant a sunflower, and then we're going to water the ground. It's just oh, and then I need to traverse the grid. So then, well, xpos is, yeah, it wants to be that. Because we want to break out of this. No, my xpos. We didn't traverse properly there. Where's my traverse? Where's my traverse? Traverse grid. If pos y is move is less than the size -1, then we move east, otherwise we move north. While x is less than size -1 and y is less than size. There we go. That's not equal to size. Can't be an or, right? Like, if there's an ore... So while I'm here, I want you to check the ground. Basically, I want... If you're here, you're at 5-5. Maybe that? While that is not equal to size -1, and that is not equal to size -1. Right. Reset drone. Size is equal to 6. As soon as it gets to 0.5, the second half is true. Yeah, but this is false. This is false. As soon as it gets to 0.5, the second half is true. This is true. Yeah, so it's breaking out. While x is less than 5, and y is less than 5, do this. As soon as one of them is false, the whole thing is false. It's the ore. It needed to be an ore. Right, okay, so if you're equal, can I do I need a do while. Where are my loops? Loops. For loop. While loop. Does Python have a do while? Loops in Python, there are two types of loops, while or for. How to emulate a do while? You can do while true stuff, else if fail condition. I kind of don't want to do. So What I could do, I could say for X size -1, for Y in range size -1. Is that right? Oh. Yeah. Oh, and range gives you not inclusive. Yeah, it's exclusive. Range is exclusive. To remember that. Okay, let's clear that out. Okay, that's good. So now we want to measure grid. So again, we want to say for X in range size, for Y in range size, and we go to so we're going to go to each spot. So our power so we want a tuple here of the measure and the XY. And we append that. And then we return power. So we say power equals measure grid, and then we'll print power. Oh, we say we need to do size equals get underscore world. What didn't we like there? Oh. There. So then we measure. So these are our powers. So these are our powers. Okay, good. So this is our array now of powers. So now we want to sort right, so that's our power. Do I have I don't have sort. So let's. So I have my array. So it's Python-like. So there aren't all the utilities. So try doesn't exist. For example, sorted isn't a function. And yeah, various commands are unlocked by. So, for example, I don't have access to sort at all. We can get time. That's kind of nice. Get the water. We can do a flip. We can print things. We've obviously got our list. We can measure. We can take the minimum and the maximum. We can take the absolute. We can get a random number. Oh, we've got a list. I wonder if can we do something on list? So max. So hang on, let's go. Let's start this. So let's just do this in our little playground here, and let's do a print max power. Right. So if we give it a list, 1, 3, 10. That printed us 10. But it doesn't tell me the index of 10. So now if my instead is a tuple, because this is my data structure, like this. So hang on. Oh. Would you know the minimum of that? If I set you to 0, do you know the minimum then? I set you to 11, do you know the max? So this does. So you can find the max like that. I assume if I go like 9, 3, it's not going to go. I set this to say. But it doesn't give me the index of that. Because this is what I want. I need to know the index of that. Because I can find it. What have we got in lists? We have a look at lists. So what can we do on lists? So we can pop. We can insert. So we can insert, we can pop, and we can remove and append. The hard part is to find. This is kind of why I want to sort, because then I can just pop the list. And I might have to have a look at a Python insertion sort. So a Python insertion sort iterates over the array starting from the second element, grabs the current element as the key, and then moves elements greater than the key one position ahead. So if I do, let me steal this from the internet. So this is my insertion sort. And then I need you to return the array. So if I print insertion sort power, let's have a look at our output. So that has actually sorted it by the first thing in the array. Which is perfect. So I can go insertion sort power. So that is now a sorted array. And now I want you to harvest the sunflower. So if I give you sunflowers, so I want you to harvest sunflowers. So this list is from smallest to largest. So while sunflowers so while the length of sunflowers is greater than 0, I want you to say power XY is equal to sunflowers dot pop length of sunflowers. So that'll grab the end. Then I want you to go to XY. And I want you to harvest. So now you're measuring. Then you're going to sort the array. And it needs to be the length of the sunflowers minus 1. So we measure, then we sort, and then we harvest. And then we run again. That is amazing. That is awesome. So yeah, I just stole that sort off the internet. Yeah, so now we do power equals 2000, and we add this into here. So what I would really like to be able to do is jump to this. Like find this. So I just go elif norm items dot power is less than or equal to power, then plant let's just add power here. And it's plant underscore sunflowers. So I'm going to put that there because that's sort of like a nice utility thing. I don't know why that was doing it a little bit weird there. I think the drone is moving so quickly now. We're also not buying fertilizer. I guess we can't afford it. Yeah, I wonder whether we actually bother with the fertilizer. I'm gonna put traverse grid here with go to. So this is my plant checker. Right here, and I'm gonna put buy seeds over here. So this is like my utility column. So this is my utility column. These are my planting stuff. So let's actually take you off, put you there. Plant trees. Right, and I just want to plant pumpkins, so let's not use fertilizer. Yeah, it's occasionally fails. Does measure? What happens if we measure here? Yeah, so that's just getting none. Yes, because this is so fast. I am half tempted, you know, instead of this reset drone. Like to do that, as we suggested earlier. Plant pumpkins. Oh no, we're on sunflowers now. So there's just a minute while it sorts, but the sort is so quick now, with power being so high. That's pretty awesome. I love that. Right, so what have we got next? So we need treasure for this. That's polyculture. Use companion planting to increase the yield. Dictionaries, phasers. So we actually need to increase these. Base equals, let's call this 1000, and then say 3.5 times base. Look at how fast that goes. Oh, that's insane. I wonder if plant trees is actually faster. So if I actually go if get underscore ground type is not equal to soil, then till. Because I think that will be quicker. Yeah, they feel like they grow a lot quicker. So how fast do pumpkins grow? It's a good idea to get pumpkins as big as possible. Oh, and we're done. Only we've hit an error. Yeah, so we could wait. So we can get the time. And then we say while get underscore time is less than start plus 2. Available functions, get the time. Clear, measure. max, absolute, random. Quick print. It turns in the time in seconds. So if the time is so if we say 4 times and then run it again. Yeah, so it does a flip for 2 seconds and then it harvests. It's not ideal, but there's no way to measure that they're all one. Yeah, there's no way to measure that they're all one. Right. I don't know what polyculture does. Grass, bushes, trees, and carrots yield 10 times more when they have the right plant companion. Companion preference is different for each individual plant and cannot be predicted. Fortunately, the companion preference of the plant under the drone can be measured using Get Companion. It turns a list where the first element is the type of plant it wants as its companion, the second, third elements are the X and Y coordinates of where it wants it. So if you plant a bush, then call Get Companion, it'll say something like entities carrots 3-5. Each plant chooses this randomly, but it always choose a different plant itself. The position can also be in any plant within 3 moves. If there is no plant under the drone that has a companion preference, Get Companion will be turned on. I don't think I care. I don't think I care about this. I don't think this is that important because it's not too difficult. Because what you do is you plant the carrot. Let's say we plant a bush, and then we call Get Companion, and then we say plant at 3-5. So what we then say is go to 3-5 and plant this entity. And because it can only be grass, bush, tree, or carrot. Yeah, and each companion will have another plant. So then what you do is you just iterate. So you plant the next companion. But so if you plant carrots at 3-5, then harvest the bush, it yields 10 times more wood. And it doesn't care about the growth stage of the carrots. So you could, for each position, plant it there, then go plant the carrot, then go back and harvest. But this just runs so quickly anyway. I don't think it matters, and it's only grass, wood, and carrots, which are relatively easy to get. I don't think we care. Because I could just... The other thing I can do is I can expand this. Yeah, it could be an interesting exercise. The next expansion is... 6.5. So also we've made this bigger. Like this is so fast. This is so fast anyway. And actually, what I think I want to do is take this, and because power makes us faster, I think I want to do power first. Because then I'm assured that I'm not going to run out of power. So now I've got plenty of power. I harvest all my trees. Until we get 500 trees. Because what I'm trying to get to is mazes. Mazes are the next thing I need. So that needs 2,000 carrots, which I'm going to get, and 3,000 pumpkins. So I think if I can get mazes unlocked, and then we can have a think about mazes, and then I'll call it for the stream. So we're on pumpkins now. Got quite a few there that didn't quite hit. But this is going to give us so many more pumpkins at once because it's bigger. Right, okay, mazes. So, mazes. If you use fertilizer on a full-grown bush, it will grow into a maze of hedges with a 10% probability. For some reason, drone can't fly over the hedges, even though they don't look that high. There's a treasure somewhere hidden in the hedge. Use harvest on the treasure to receive gold equal to the area of the maze. If you use harvest anywhere else, the maze will simply disappear. So let's reset the drone. Let's buy some fertilizer. And now let's plant a bush. And then use item. So now we've got a maze. So what we need to do is find the treasure and harvest it. So if we go print get underscore entity type, it's a hedge. So if it was there, it'd be entities.treasure. Okay, fine. Mazes don't contain any loops. So this is assured not to have any loops. Mazes don't contain any loops unless you reuse the maze. So there's no way for the drone to end up in the same position again without going back. You can check if there was a wall by trying to move through it. So if we say print move north, that is true. But if we do it now, that is false. If you have no idea how to get the treasure, take a look at hint 1. It shows you how to approach a problem like this. For an extra challenge, you can also reuse the maze by using fertilizer on the treasure. So let's just go get the treasure. So we are at the treasure, and then we can print get entities underscore get entity type. So that is treasure. So for an extra challenge, you can also reuse the maze by using fertilizer on the treasure. This has a 10% probability of increasing the treasure by 1 full maze and moving it to a random position on the maze. So if you call measure, it returns a tuple 60, which is where it will go next. Each time the treasure is relocated, a random wall may be removed from the maze, so reused mazes can contain loops. Note that loops in a maze make it much more difficult, so if you're a beginner, you may not want to reuse mazes. Reusing mazes doesn't give you more gold than spawning a new maze. It's only worth it if the extra information and the shortcuts help you solve the maze faster. The same maze can be solved a maximum of 300 times, corresponding to 299 relocations. After that, fertilizing the treasure won't have any effect anymore. So if I go use item, items.fertilizer, it's failed. It is that, isn't it? If you harvest it, it'll disappear. I'm gonna reuse it. Use fertilizer on the treasure. There we go. So it's gone down there now. Which I think also has meant that yes, there's still a gap there. There isn't a loop here. Yet. So yeah, we've got a maze solving to do. Which is interesting. So we'll have to have a look at. Oh, there is a loop? Oh yeah. Yeah, I see the loop. Here. So there's very simple maze solving when you don't have loops, which is, you know, hold your left hand out and just follow the left hand wall. So I've been thinking about this. Essentially, we want to keep track of our facing. And every time, you know, if essentially if we can turn left, we do. Yeah, if we can turn left, we do. But it's like how we can do that. The other option is trying to trace the maze, understanding, you know, if you can move in a particular direction from each square. But that'll be for another time. So that'll be for now. So thanks for watching. I hope this is entertaining. I quite like this. I think this is a very cool game. So next time I play this, I will try and get the treasure. We'll implement a simple maze finding, and then we might have a look and see if we can find some more advanced ones. Maze solving. See what's out. But yeah, if you like this, it's available on Steam. I wonder if it's on Humble. Because if it's on Humble, I am a Humble partner. The farmer. No, it's not. It's not on Humble. It feels like it should be on like Humble. The farmer was placed. Yeah, it just looks like it's Steam. A shame. But if you are buying games, you're buying from Humble. I am a Humble partner. Link is in chat. Anyway, that'll do for now. Anybody streaming? Yeah, so I'll catch you later. Thanks for watching, folks.